Welcome. We're going to talk about how to get the basic energy calculations done for your roller coaster. This is just like the bottom level of energy calculations. We're going to start out with my little roller coaster up here. You'll notice that I have like some points, point 1, 2 at the top of the loop, 3 at the bottom of the loop, 4, 5, 6, jump in the air, 7, 8, and 9. You don't have to have 9 points, but these are my examples. And we're first going to start by calculating energy, so we need the heights. And I've given some heights here. 1 is going to start 1.5 meters high, 2 is 1.4. At the bottom of the loop is lower, so it's 0.4, blah, 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 all the way down till you get down to the bottom, which is 0 meters off the ground. GPE has a formula of mgh, where m is the mass, g is the acceleration due to gravity. You can either use 9.8 meters per second squared or 10 meters per second squared. 10 is easier, 9.8 is more accurate, both are good. And h is the height. I've already got some heights, so if I want to calculate the GPE, the thing I really need is the mass. You can mass your marble with a scale, but most marbles are between 2 and 5 grams, so let's just say that my mass is 5 grams. Now I need to convert that to kilograms. This is good practice for unit conversion. I'm going to take my 5 grams and I want it to become kilograms. I put it over 1, I say is grams kilograms? No. So I want to cancel out grams and get to kilograms. And the conversion factor here is that 1 kilogram is 1,000 grams. That's on your conversion card, probably in meters and kilometers. Grams cancel, I do the math, 5 divided by 1,000 is 0.005 kilograms. So that's the mass of my marble. And that will always be the mass of my marble for my example. Your mass might be different. So then we're going to go calculate GPE. Its mass, I'm going to use 10 for my acceleration due to gravity because that's easier, times whatever the height is. So 0.005 times 10 times 1.5 is 0, wait, that can't be right, 0.005, 0.005 times 10 times 1.5 is 0.075 joules. 1.4 times 0.005 times 10 is 0.07 joules. 0.4 times 0.05, 10 is 0.02 joules. And when you're at the bottom, there's no height. So you're going to have no joules of GPE. So now we've kind of done our GPE. That wasn't too hard. Now I want to make room to calculate the kinetic energy. Kinetic energy plus potential energy is equal to total energy. So I'm going to have a column here of total energy and a column of kinetic energy. And then later we're going to do velocity. At the very beginning, at the top of my roller coaster, there is no motion. I'm just dropping it. So at that point, the kinetic energy has to be 0. And thus, the total energy is whatever the GPE is at the top. And if I am conserving energy, it is the same total energy all the way down. Everything is the same. My total energy is always the same because energy is conserved. So now if I want to calculate the kinetic energy, I just have to take the GPE away from the total energy. So this is going to be total energy minus GPE. Or in this case, 0.075 minus 0.07 or 0.005 joules. That's my kinetic energy there. For this next one, I'm going to take 0.2 away from 0.075 and get 0.055 joules. And at the very end, there's no GPE, so all of the total energy has become kinetic energy. So that's 0.075 joules. And that wasn't too hard. I'm going to erase this and put it over here to give myself some more space. So now I need to find velocity, and I'm going to get that from the kinetic energy equation. The equation for kinetic energy is that it's 1/2 m velocity squared. So this one, I'm going to end up doing a bunch of math written out to follow my work. It's going to get a little messy. But if the kinetic energy is 0, that's easy. The velocity is 0. If the kinetic energy is 0.005, I want to set up an equation. 0.005 is equal to the mass, 1/2 the mass, which coincidentally is also 0.005, times v squared. Doing this math problem, the 0.005's cancel out, and I get 2 equals v squared, and the square root of 2 is 1.4. So my velocity here is 1.4 meters per second. Next up, 0.055 joules. 0.055 kinetic energy equals 1/2 mass v squared. Divide both sides by 0.005. 0.055 divided by 0.005. I get 11 equals 1/2 v squared. I get 22 equals v squared. I take the square root of 22 and I get 4.69 meters per second. It's getting faster. That's 50 meters per second. Should it be getting faster? Yes, it should, because as it goes down, it speeds up. In your real roller coaster, it won't actually be getting faster the whole time because it will lose energy to friction. That's harder math, and we'll do it next. Last but not least, 0.075, if that's my kinetic energy, that's 1/2 the mass times v squared. 0.075 divided by 0.005 times 2 is 30. 30 equals v squared, take the square root of 30, and that's my fastest yet, 5.48 meters per second. So now I've got most of my calculations. They're pretty well done. That's how to do the basic energy calculations for the roller coaster.